Section 4.1 General Properties of Aqueous Solutions. A solution is a homogeneous mixture of two or more substances. Remember, homogeneous means that everywhere you look, it's exactly the same. So it would be like Kool-Aid. Everywhere you look, you have the same color, the same sweetness, the same everything. One side's not thicker than the other. There's nothing floating in it. It's homogeneous. So if you have a homogeneous mixture of two or more substances, it's a solution. And you make a solution when one of the substances, which is the solute is dissolved into another substance called the solvent. So whatever is being dissolved is the solute, and whatever is dissolving is the solvent. Normally, whatever you have the most of is the solvent if you have two liquids. So in this case, I have a picture of water. That's the red with the two whites. That's H2O, water. And then you've got some methanol, which is methyl alcohol. You've got 2 or 3 particles there dissolved in the water. Whatever you have the most of usually is the solvent. When water is the solvent, it's called an aqueous solution. And aqueous is just the Latin word for water. So it's a special kind of solution where water is the solvent. It's so often the solvent, you see it's very many times it's the solvent. So here is a water solution. So you have the water molecules, the red and white water molecules all over the place. And you have a grain of salt. This is table salt, which is sodium chloride, NaCl. And NaCl is made up of the sodium, which is the little guy, the purple guy is the sodium, and the chlorine is the green anion. So the positive cation is the purple, the green anion is the chlorine. And what happens is that the water surrounds these two. So the water kind of comes over to the edge, takes one off, and then surrounds it. And you can see that the positive sodium is being surrounded by the red regions of the water, and the green negative cation chloride is being surrounded by the white regions of the water. So you can already see that water is something special. It has two different sides to the molecule and can essentially rip apart positives and negatives. And this is called dissociation. Whenever something is separated into positive and negative ions, so like an ionic compound like sodium chloride, which is ionic, and it breaks apart into ions, that dissociates. So the positive dissociates from the negative dissociates from the positive. Now, if you have positives and negatives in a solution, something interesting can happen. Those electrons, which are the negatives, all right, the negatives have more electrons than normal. The positives have less electrons than normal. That's a cation. The anion was more electrons. Those electrons are free in the water to float towards, say, a cathode. So if you have a positive electrode and a negative electrode, and you have, say, an electron, the electron is going to migrate towards the positive. And so if you have any anions, let's say a chloride, the chloride has a negative, it is free to migrate because it can just float in the water towards the positive. Likewise, if you have a Na, it is a positive, it can migrate towards the negative just because it's oppositely charged. There's an attraction there. It's an electrostatic attraction. If you put something in water or some other solution that will break apart into ions, then you have what are called electrolytes. And you see the word electricity here. Electrolytes, meaning the electron is free to move. So you've got movement of the anion towards the positive and movement of the cation towards the negative. And because you have this movement of charged particles, you can have electricity. That's what electricity is. You can complete a circuit. So they've got a conductivity tester here, which is a light bulb, It goes into the top and just goes into a probe that goes down into the solution. Then a second probe is coming out of the solution and then back to the bulb. And if electrons can move in that solution, then electrons can move in the circuit. You can complete a circuit and the light bulb will shine. So the first thing that they've done is they've put in sugar, sucrose, C12H22O11, sucrose, and sucrose does not dissociate. The water kind of holds it a little bit, so it does interact slightly with the water, but it doesn't break apart into ions. And because it doesn't break apart into to positives and negatives, those positives and negatives do not migrate towards the electrodes. You get no electricity, and the light doesn't shine. If you put in sodium chloride, table salt, into that solution, that the sodium is free to go to the negative, the chlorine is free to go to the positive, and the light will shine. So electrolytes are charges that have come from something that dissociates. Normally, ionic bonds or strong acids will break apart into ions, and these are electrolytes. So a strong electrolyte completely dissociates. Now that's what strong means here. It means it completely breaks apart. A weak electrolyte only partially breaks apart. So you don't have just the positive and the negative. You don't just, in the case of sodium chloride, that's a strong electrolyte. It would completely break apart into sodiums and chlorides. But if you were to have something else that doesn't completely break apart, where you have some of the molecule and then some of the ions, then that would be a weak electrolyte. So an example would be vinegar. So if you have acetic acid, which is HC2H3O2, all right, it does break apart, and you're going to get some H+, and you're going to get some C2H3O2 negative, but you're also going to have some acetic acid. So all three of these will be in the water. That is what weak electrolyte means. It means the electricity is based upon the amount of charged particles that you have. And so since not all of this is going into charged particles, some of it's staying complete, you would have maybe a weak, it would light the bulb, but it wouldn't be very bright. So here's just a schematic. This is the sugar on the right, and it's just floating around. It doesn't have an attraction to the positive or the negative, and so there's no bulb bright. If you have positives here, it's attracted to the negative. If you have negative charges, it'll attract to the positive, and so you end up with electricity. So to review, electrolytes are substances that dissolve in water to produce ions. So sodium chloride example, sodium positive, chlorine negative, that would be an electrolyte. A non-electrolyte may dissolve in water. Sugar can dissolve in hot water, but it doesn't break apart into ions, and so there would be no electricity or current in the water, and so it's called a non-electrolyte. Strong electrolytes completely dissociate. They completely break apart into their ions. Weak electrolytes, this is the acetic acid again, weak electrolytes will have some of these, but a lot of this left over. So it's going to break down partially or just a little bit. So strong acids, these are ones that are strong electrolytes. Strong acids completely dissociate. They actually don't dissociate. They call strong acids ionize. Dissociate normally means that I have ions already, and those ions are in a bond, an ionic bond. When you put them in a solvent like water that can rip them apart, they become just their ions floating around, and that's called dissociation. If I have something like a covalent bond, HCl, like hydrochloric acid, they do become ions. So that's why it's a strong electrolyte, but they're not dissociating because they're not already ionic. Remember, this is a nonmetal, H is a nonmetal, Cl is a nonmetal. That means they share electrons, and since they share electrons, they're not already ions, But when you put this in water, since it's a strong acid, it breaks apart into ions. So there is a slight difference between ionize, so strong acids ionize, any type of inorganic compounds would dissociate. So strong acids will ionize. Ionic bonds, like the NaCl that we talked about, they dissociate. So anything that dissociates or ionizes completely is called strong. Anything that ionizes or dissociates partially, and mostly these will be weak acids. So these are going to ionize, and they partially ionize, so that you still have lots of the original, and then a little bit of the H and a little bit of the leftovers, and that is called a weak electrolyte. Then non-electrolytes are anything that doesn't have any charges whatsoever. They're not strong, they're not weak electrolytes, they're just molecular compounds. They are sharing electrons, and they don't break apart as ions, and so you put them in the water and nothing happens, it just falls to the bottom.